data. Lesson 6.5, protecting data. So earlier we talked about encoding. Encoding is not a way to protect data, it's a way of storing data. To protect data, we use something called encryption. So it's basically the data gets put through a cryptography algorithm, so using math, and it produces an output that hopefully can't be deciphered very easily. So this is the purpose of this is to protect the data. So if somebody intercepts it, they can't understand what it is. Decryption is the undoing of that process. Okay, so in order to encrypt and decrypt, a key is going to be used. So basically a key is to tell us what algorithm we need to be able to encrypt the data or decrypt the data. Keys can be symmetric or asymmetric. So a symmetric is a shared key. So basically the sender and the receiver both have the same key. The sender uses the key to encrypt, the receiver uses the key to decrypt. Then we have an asymmetric one. So an asymmetric one is actually you have like a public key that everybody uses to encrypt the data. However, each person has their own private key to decrypt it. All right, so that was a little bit more complex. So this is not an encryption method that you would ever use in real life, but to understand how encryption is without extreme high levels of math, the Caesar cipher is a very simplistic, it's probably it's like the simplest encryption method you could really teach. So the way the Caesar cipher works is you have the alphabet and you're given an offset. So for example, let's say we have the word cat and we want to encrypt it using a Caesar cipher with an offset of 4. So what you would have here is you would first think of all of your letters. Okay, so here's all the letters A through Z. The offset tells you, okay, so like the letter A, to encrypt it, we would go 4 over. Okay, so we 1, 2, 3, 4. All right, so the letter A gets encrypted with an E. The letter C, if we do 4 units down from that, 1, 2, 3, 4, that would be the letter G. And then for T, if we do 4 from that, 1, 2, 3, 4, that would be an X. Okay, so the offset tells you like how far from that number you would go down. And if you get to Z, like if you get to down here, basically like if you're trying to do this, you would just go all the way back to A. It just kind of wraps around. All right, so if you wanted to do 4 from here, you would go 1, 2, 3, 4. You would actually be at the letter D. You can also encrypt using exclusive OR operators. So some of those logical operators can be used. Remember, exclusive OR means if they are the same, it's off or false, 0. If they are different, then it's true or 1. Okay, so let's say this message is encoded as 01001001001, so like basically binary, okay, because that's how data is stored. If we wanted to encrypt the message, we would have a key, okay, so the 8-bit key, is what we use. So for every 8 bits of our message, we would do an exclusive OR on those 8 bits with this key, okay, so the first 8 bits exclusive OR with the key gives us this result. So that would be the encryption for the first part, the first 8 bits. Then the last 8 bits, exclusive OR with the key, that would give us the last 8 bits. So this is now our encoded message. I'm sorry. Oh, I didn't mean encoded. I meant encrypted message. Okay, so here is the actual code for a Caesar cipher. So let's kind of take in what you know about programming and what we talked about with Caesar cipher, and see if you can figure out, like, try to trace the code a little bit just to kind of see what's going on, but see if you can take this word wham, okay, so this is like our message, and perform the Caesar cipher to get the encrypted word. All right, so this is really just wham, and we have a 6 as our offset there. Okay, so like the W, we would go 1, 2, 3, 4, 5, 6. So W would become C. H, we would have 1, 2, 3, 4, 5, 6. So that would go to N. For A, we would have 1, 2, 3, 4, 5, 6. That would go to G. And for M, we would have 1, 2, 3, 4, 5, 6. That would go to S. So that's really all we're doing. Let's talk a little bit about the code though. So what this is saying is, okay, we're going to start at the beginning. We're going to go all the way to the length of our word. So first we're going to look at the letter W. Okay, so this is I equals 0. All right. We are going to take word minus A. That's just to let us know that we're starting with the lowercase letters. If you were doing capitalized letters, you would do that here. Basically, it needs to know where in the ASCII chart, because really it's just using ASCII behind the scenes. It's kind of like, where do we actually start our counting? Okay, so we need to know that it is in the lowercase letters. So that's kind of what this means. So basically it's like, okay, well, our character W is this far from A, and we want to add 6 to it. Now, why the mod 26? Well, if we didn't do the mod 26, instead of after the Z, it going back to the A, it would try to do this. And, you know, it's not going to stay in the lowercase letters anymore. Remember, ASCII is a bunch of characters. So what would happen here is if we didn't have that mod, remember modulus division is remainder division, if we didn't do mod 26, it would end up treading into other territory with the ASCII. We want to make sure we stay in the lowercase letters. So this part and this part of the code and this part of the code is literally just, we want a lowercase letter. It looks like a lot going on, but that's all it means. It means, okay, we're working with ASCII, because behind the scenes, that's actually what's happening when we use characters. We want to make sure our ASCII stays in the lowercase letter range. So this subtracting lowercase a, adding lowercase a, that's making sure we're still within the lowercase letter range. Mod 26, that means when we start counting our offset, we wrap back around to our lowercase letters. So if you see this code, just kind of be aware that, there's a lot of extra stuff going on. It's just to make sure we stay within our letters. The main thing is this is a Caesar cipher with an offset of 6.